So now we're going to draw graphs of the form, the absolute of f of x. But we start by drawing the original graph. So in the first question, I have the parabola, and I'm asked to find the absolute of x squared minus 4. I'm going to start by just drawing the parabola y equals to x squared minus 4, and then using the sketch of this graph to find the absolute of the graph. So when drawing the parabola, we know that the parabola is given to us in the form of y equals to ax squared plus q. I see that a has a value of 1 and it's positive, so this is the shape of my parabola. I now need to find the turning point. The turning point will have the x value at 0 and the y value at negative 4. To calculate the x-intercepts, you let y equal to 0, so you got 0 equals to x squared minus 4. So this can be simplified either by square rooting both sides, but I am going to, instead of taking the term across, I'm going to factorize. So this factorizes nicely into x minus 2 times x plus 2. So I know that my solution is x equals to 2. So my first x-intercept will be at 2, 0. And my second x-intercept will be when x is negative 2 and y is 0. And the last point that I should find is the y-intercept. So there I let x equal to 0. So my y-intercept would be x is 0 and y is negative 4. So now let's plot the graph. So here we have the graph of y equals to x squared minus 4. I'm just going to write it down. So this is the graph of x squared minus 4. And we identify that the y-intercept and the turning point is at x equals to 0 and y equals to negative 4. And x-intercept at 2 and 0. And another x-intercept at negative 2 and 0. But if I'm asked to find the absolute value of this graph, and I'm going to do it in black. So if I want the absolute value of x squared minus 4, what I do is I'm going to reflect all negative y values along the x-axis. So all negative y values become positive. So we start with the turning point. The turning point was at 0, negative 4. It now turns at x equals to 0 and y equals to 4. So if you have a look, here's another point. When x is negative 1, we had y is negative 3. If that is reflected along the x-axis, I see now that when x is negative 1, y is going to be positive 3. Similarly, on the other side of the y-axis, on the right-hand side, I will have the point 1 and 3. So if you're drawing the graph, your markers are here along your x-axis, and all of the values under the x-axis is not what you want. You're going to draw it so that it is reflected along the x-axis. So your parabola changes shape. And all of the parts that I'm highlighting in black, that is the graph of the absolute of x squared minus 4. So my black graph now is the graph of y equals to the absolute of x squared minus 4. So in example 2, we asked to find the absolute value of a hyperbola, and the hyperbola is y equals to 4 over x minus 1. So once again, we're just going to draw the normal hyperbola and then reflect it. So if I'm drawing the hyperbola y equals to 4 over x minus 1, looking at the shape, what identifies the shape? So if I go with the general equation of my hyperbola, y will equal to a over x plus q. So A is positive 4, so I know that this graph will be plotted in the first and the third quadrant. But remembering that there's a shift because Q equals to -1, that means my graph is going to move the 1 unit down. So every y value on the graph will move 1 unit down from the graph y equals to 4 over x. The next important values to consider is the equations of the asymptotes. So I have an asymptote at y equals to -1 because that is my Q value. I also have an asymptote on the on the y-axis, and that is x equals to 0. To find points to plot the hyperbola, it's easiest to use a table and to substitute values. So I have my x and my y coordinates. I'm going to choose multiples of 4 so that it makes substitution easier, and factors of 4. So I'm going to take -4, -2, -1, 1, 2, and 4. And remember, x cannot be 0 because x equals to 0 is an asymptote. Also, division by 0 is undefined. So when I substitute x equals to -4 into my equation, and remember, I'm substituting it into the equation of the of the hyperbola, I go 4 divided by -4 gives me -1. -1 added to -1, I get -2. Substituting x equals to -2, I get y equals to -3. Substituting x equals to -1, I get y equals to -5. Now I substitute x equals to 1. 4 divided by 1 is 4, minus 1 gives me 3. When x is 2, I see that y is going to be 4 divided by 2 is 2. 2 minus 1 is 1. When x is 4, I have 4 divided by 4 is 1, and y is 0. So here I've actually found an x-intercept as well. So I have an x-intercept at x equals to 4 and y equals to 0. So we have enough points, and we're going to go and plot the graph. So here is the graph of the hyperbola. So this is the graph of your function y equals to 4 over x minus 1. And we have an asymptote at y equals to -1. And we have another asymptote at x equals to 0. So once again, if I'm asked to find the absolute value of this graph, what I'm going to do is I'm going to reflect along the x-axis, so all the negative y values will become positive. So I'm going to draw the absolute value in black. So I'm now drawing the absolute of 4 over x minus 1. This is the graph that we are now sketching. So I'm starting on the right-hand side. So at x equals to 4, I have y equals to 0. But for any value greater than 4, you see that you have negative y values. So this arm will be reflected along the positive x-axis. So this is the graph. Right, so if we look to the left of the graph, let's just take a few points. We see that when x is -4, y had a value of -2. So if it's reflected along the x-axis, when x is -4, y is now going to be +2. Let's take another point. Sorry about that. So the next point that we're going to plot is we see that when x is -2, y is -3. So I plot the point. When x is -2, y will be +3. So it's reflected along the x-axis. And I have another point here. When x is -1, we have y is -5. So we plot the point x is -1, y is -5. So we have 3 lovely points, and we can draw the graph. So I've joined those dots, and so the black graph is the graph of the absolute of 4 over x minus 1. So just to recap, when you're asked to draw the absolute of any function, whether it's a parabola or a hyperbola, what you do is you just draw the graph of the normal function, and then you're going to reflect any negative y values along the x-axis. So all your negative y values become positive, and the absolute of the graph will be the graph where all the negative x values become positive.